Here is the supplementary video for our ECCV submission 799, titled EvSign, Sign Language Recognition and Translation with Streaming Events. Two contributions are summarized in our paper. First, we release the EvSign benchmark, which is the first benchmark for event-based continuous sign language recognition and sign language translation. It provides sufficient corpus with large-scale vocabulary size and can boost the development of event-based sign language tasks. Second, we propose a transformer-based framework for those tasks, which is to fully exploit the sparsity and high temporal resolution characteristics of events. Event camera, a biologically inspired sensor, detects the variation of intensity along time. Rather than encoding visual appearance with still images, it generates sparse and asynchronous event stream with extremely high temporal resolution, high dynamic range, and low latency, which is ideally suited for sign language tasks. Compared to RGB videos, event data provides a smoother trajectory and sharper boundary without motion blur, and it only focuses on moving target, thus contains less redundant information such as background and textured clothing. Furthermore, from a privacy protection perspective, event cameras can avoid collecting facial information of sign language users. However, current researchers have not paid much attention to the study of sign language tasks based on event cameras. In this work, we provide a new dataset, namely EvSign, to unveil the power of streaming events in sign language tasks. Main features of the proposed dataset can be summarized into three aspects. First, it is the first benchmark for continuous sign language recognition and sign language translation. Compared to the current event-based sign language datasets, which only provide word-level event for isolated sign language recognition with short duration, EvSign provides 6,700 sign videos with real events. The corpus is sourced around our daily life, such as shopping, education, medical care, travel, and social communication. Second, the data is recorded by a professional sensor with higher resolution, which can capture more hand details and subtle motion. Third, we provide both gloss and spoken language annotations, contributing to a large-scale corpus with adequate vocabulary size. Here are some samples in EvSign dataset. The event data contains richer motion information and sharp boundaries, which can promote the development of those tasks. We will introduce the proposed transformer-based framework. Two main components are introduced to fully exploit the sparsity and high temporal resolution characteristics of events. First, we employ a sparse backbone for streaming events, thereby reducing computational load significantly. Second, we propose a hierarchical temporal modeling for high temporal resolution events to learn the temporal coherence, which consists of local token fusion and gloss-aware temporal aggregation modules. Our framework contains of three key parts, including sparse backbone, local token fusion, and gloss-aware temporal aggregation. First, taken the event representation as input, the sparse version of ResNet 18 is used as feature extractor, which generates the visual tokens. Token fusion module, to build an effective representation for continuous actions within a short duration and reduce computational load. The module contains two multi-head self-attention layers within local window to model temporal relationship among neighboring timestamps. Also, two max pooling layers are introduced to fuse the tokens, thus decreasing the token number. Finally, in gloss-aware temporal aggregation, we decouple temporal information into intragloss and intergloss cues and model them individually. As for intragloss temporal modeling, we propose a gloss-aware mask attention, which can adaptively ensemble the tokens belonging to the same gloss by setting an attention mask. The mask is to control where to attend and learn gloss-level representations. After obtaining intragloss tokens, the intergloss temporal cues are learned by a global self-attention layer. The gloss-aware tokens are obtained, which are passed to recognition and translation heads for both tasks. We conduct analysis on both sign language recognition and translation on Phoenix 14T and EvSign dataset. As shown in Table 3, our method achieves the best performance in all metrics. Compared to the methods using RGB inputs, event-based methods show superior results on EvSign dataset, which demonstrates the power of streaming events. The comparison results on SLT task are shown in Table 4 and 5. Our method also achieves favorable performance in terms of blue and rouge. Notably, thanks to the sparse backbone and efficient temporal aggregation module, our method for sign language recognition obtains competitive results with less than 1 gigaflops and 14 million parameters, which is significantly less than other algorithms. Furthermore, we visualize the learned mask in gloss-aware mask attention. We claim that it is capable of adaptively aggregating tokens that belong to the same gloss, thus modeling the complete sign language gestures and eliminating the interference from different glosses. Thanks for watching. We hope that the submission aligns with the distinguished standards of ECCV.